Okay, cool. Let's let me repeat this again. So this is what we are learning today, client server architecture, and basically this is the task we are planning to do, digit extractor, which is supposed to do these three steps: takes a string, processes the string, and extracts the list of digits to this. And let's say we've written a text like this. So if we look at this diagram, let's say this is our um, let's say this is our hang on. Let's say this is our you know, the program. Okay, and what happens is this program becomes really popular, so users try to use the programs. So what we do is one of the ways of doing this thing is by like deploying this executable.exe file into each of these users. Okay, and every time you have a new user, you will go ahead and put this piece of code sorry, put this piece of code in the user's computer. And if, let's say, tomorrow you have a new requirement where you say that I have to add one more step. Okay. Then what happens is, in this case, all these executables become invalid. So you chuck them out. These red ones here basically mean that these were the old executable files. And now the new executable with the new step gets deployed in these things. There are two types of problems with this architecture. Every time you have a new user, you have to go and deploy it on his machine. And if his machine is running the same operating system, it is fine. But people have different operating systems. Some of them have Windows, some of them have Linux, some of them have Mac OS, some of them have Android, right? So you don't, so for every operating system, you would have to have a different executable. So if you have one release, this is one release will have 5 different executables, and depending on the operating system, you would have to inject it there. So as the number grows, it becomes very difficult to maintain. So what we do is, instead of doing this thing, instead of putting the processing inside the user's computer, why don't we put it somewhere here? This is where the processing would be sitting. Whoever needs to use this, so this will be like a single computer sitting somewhere. Any user that needs to get something done, they would basically contact this server. I mean, they would basically contact this unit, and it will process it and it will get the response back. Okay, this sort of communication is called a client server architecture, where this green box here represents the server. Why? Because this is where the processing power is sitting. This is where the processing is going on. You as a client would approach this server and you would get a response back. So the thing that you send, the query that you send the server, is known as request. The answer that the server gives you is known as response in a typical client server architecture. This is what we have learned so far. Okay, now let's I have to keep the chat window open. I think I always forget the recording. Okay, so this was the client server architecture. Does anyone have any questions on this? I think it's a very simple thing, so people shouldn't really have a question on this. But if you have any questions, let me know. Cool. Okay, so let's understand something about stateful and stateless communication. Okay, so in it, all of these things, right? Stateful, stateless, rest, all this everything. It all comes when you are talking about a client server architecture. Okay, so what exactly is a stateful transaction and what exactly is a stateless transaction? Let's take a look at this diagram. Okay, imagine that you have a server which does two things. Okay, let's call this your server. Okay, okay, this is your server. Okay, now this server does two things. The first thing that it does is log in. Okay. I'll take a very simple example. Okay. So let's say this is a server which stores information like your name, address, phone number, and all of these things. Okay. And if you need to retrieve your information, you would be talking to this server, and this server basically does two things. It has two methods. One method where you can basically view your profile, but the condition is that if you want to view the profile from this server, you have to be logged in to this server. Okay, so how does that happen? Let's imagine that you have a client like this. Okay, I'm going to use this color for client 1. Okay, this is your client 1. So this client sends a, and guys, today's class is mostly going to be theoretical, so just don't worry much about this. Okay, what is the matter with this? Can I increase the, no, give me a second. Okay, yeah, cool. Let's say your client calls this login method. Okay, sorry, let's just say that your client is trying to view the profile. Okay, when it's trying to view the profile, the server basically keeps a track of one thing. One second. Let's say the server is keeping this particular information about the client in the server itself, in the machine itself. Okay, it could be many things. It could be a database sitting in that machine. It could be a cache sitting in that machine, or it could be in the RAM of that machine that this information is stored. Okay, but let's say you've written a Spring Boot application which gives two of these functionalities, where someone can view profile, someone can log in. And basically the condition is if somebody wants to view the profile, they have to log in, they have to be logged in. Okay, so when your client 1 requests for this and he tries to view the profile, he gets the login error, so you direct him to the login page. This is what happens with Facebook, right? You cannot just simply type facebook.com. If I type facebook.com, right, the first thing I see is login, because behind the scene I am trying to fetch the profile and Facebook realizes that I am not logged in. So it basically shows me the login page. That's the same functionality that happens here. Okay. Now, once the client logs in, okay, what the server does is the server sets this to true. Okay. So the next time the client's requests for a profile page, the server basically checks, is this client logged in? Yes. So show him the profile picture. This works fine. Okay. Similarly, like client 2, you have one more client. Sorry, just like client 1, you have one more client, which is client 2. It also does the same thing. And for this client also, this flag is initially false, and then when he logs in, this is true. Okay. Now, every machine has a capacity. Okay. There is a certain number of capacity, certain number of clients that one machine can handle or one server can handle. Okay. If the number of clients go beyond that number, let's say this server can only handle 2 clients. So the moment a third client comes, the third client's request will either get dropped or it will have to wait for a very long time. That's why you see like government pages buffering, because they cannot handle the request. Okay. So what you then decide to do is, in order to deal with this situation, you go ahead and you create one more server. What I'm going to do now is I'm going to name this as server 1. Okay. And I'm going to name this as server 2. Okay. Cool. They will have the same things because it's the same Like it's a different machine, but it's running the same piece of code everywhere. So you have the same logic. Only difference is because it's a new server, this guy is false. Okay, you add a new server. Then what happens is you have, let's say this is able to handle client 3 and client 4. Okay, after this two cannot handle anymore, so you deploy one more server. Okay, doing the same thing. Let's call it client n. Okay, so as your load increases, this is called the increasing of load. As your load increases, in order to handle the load, you basically increase the number of machines on which your application runs. Okay, now let's say this guy is handling just client 3 and 4. This guy is handling n number of clients. This guy is handling client 1 and 2. Supposedly what happens is this server crashes. It becomes non-functionable. Okay, so okay, before I get it there, let's say client 1 has requested to log in. Okay, so for client 1, this value was initially false. He sends a login request, it becomes true. Okay, now he is going to send a new request. Okay, is going to send a new request. I'll just leave it up to this. And what is this request here? Let's just say that this request is view profile request. Okay, while this view profile request is coming to this server, something happens. The machine goes down, or the machine runs out of memory, or the RAM crashes, or the hardware crashes, or the network goes out, internet goes out. Basically your server 1 goes down. Okay, then what? As soon as your server goes down, you decide, okay, there is an incoming request here, so let me do this thing. Let me say that all the clients that we're talking to this server, let them talk to this guy. Okay, so what happens now is this guy sends, so this request which was headed to this server is now rerouted to this server, right? When it comes here, it doesn't see the view profile, it sees the login page. Can you tell me why? Can anyone tell me why?
Because is logged in is false at server 2.
Exactly, because for this client 1 does not even exist here. The logged in is false for this client. What does that mean? Whatever information about that client was saved here is now lost. It's gone forever. This thing, this particular information that the server was storing only to itself, this is called a state, the state of the communication. Okay, it is usually sent in form of cookies and sessions. Okay, so if the session and cookie information is being saved in the server's memory, be it the RAM or the cache or the database, it is only saved in the server. Like whatever information is stored here, it doesn't go out to this or doesn't go out to this guy. Okay, which means when this goes down, okay, all the information, if this guy comes here, he's a new guy here, this server does not even recognize this guy. So for this guy, the default value is false, which means that he is seeing this login page, whereas he actually sent the view profile request. Now imagine you're in Amazon shopping. Okay, you have 17 items, you have added all those 17 items to your cart. Okay, and they have all been added to server 1. The moment you're about to check out, this goes down, so you're rerouted to server 2. Server 2 has no information whatsoever as to what items you added to your cart. Server 2 shows you, hey, you need to log in. That's it. That's a very bad experience, right? This sort of communication, right? This sort of architecture where the server stores the state of the communication, this is called a stateful architecture, okay, or stateful communication, where the state is being saved by the web server. Okay, this is a very bad practice because every time a new client is added, the major problem here is that this state is maintained by this server, And anytime something happens to the server, nobody has a clue of what this is going to happen. If you're like deep into some transaction, you made a bank payment, this server is supposed to return a transaction, a confirmation of that payment to you, but it goes down. This server has no information. So it's extremely dangerous, and it's also not scalable. You cannot scale it in this way. Okay. So this, to basically deal with this, we came up with another architecture. Okay. So I'll just do this thing. I'll just copy all of this information here. Let me just copy these boxes. Did you understand, guys, what the issue is? I understood that Mazar understood, but
Yes, sir.
did everyone understand? Cool, man. If you understand, it's good.
Yes, sir. Yes, sir.
Cool. Okay. Let's see what we have done here. How we are doing things differently here. Okay. All right. And let me just copy paste the boilerplate stuff. I don't know if I can multi-copy. Can I copy all of them? Yep. 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 Yes. Cool. All right. Okay. We're going to do something different in this time. Okay. This here. Array, yaar, what is this? Wow. Okay. It looks exactly like the square. Okay. Never mind. Okay. This is our database. Okay. So how are things different for this thing? Okay. All of these servers, they provide the same functionality, but this information, this state that was being saved in this guy is now being saved in this database. That's the only difference between this and this architecture. Okay. I'll tell you how this is an improvement. So let's just say that all three of these servers talk to this database. Okay. Yeah. Cool. So let's do the same thing again. Client 1 sends a login request. Okay. What was happening earlier was that this server was saving that logged in information. This server was saving the state of that client, okay, on the server itself. Instead of doing that, there is a database component which is shared by all three of them. Okay. So what we did was we extracted out this piece of information. We extracted the state out. We're still maintaining the state, but we are maintaining the state in a place where it is shared by everyone. Okay. Which is the database component here. So now what happens is, let's say this guy has sent a login request. Okay. This guy has sent a login request. Okay. It's fine. It's trying to send a view profile request. Okay. Now, what happens is at this point, this server crashes. Okay. Sorry, this color, this server crashes. So this is where the request will be mapped to, right? This is the server that will now handle the mapping. But because the state is being saved here, when this view profile request comes here, this server will call the database. Hey, this client one is trying to talk to me. Is he logged in? The database will return saying, yes, this guy is logged in. So he will show this view profile information back to the client. This is the only advantage of the server, stateless service or stateless architecture over stateful architecture. This is one major advantage. And this is also highly scalable. There's a concept of scalability, which may not be very easy to understand for freshers, but those people who are working in the industry, for them, they must have come familiar with this term, scalability. Basically, scalability means how efficiently your server can handle the load. You must have seen, like, when there's a huge number of bookings happening somewhere, the site goes down. It is because if there were 30 servers allowed to handle it, suddenly the number of requests or the load factor became so high that the 30 servers were not enough to handle it. Okay, so ideally in a stateful architecture, it becomes very difficult to handle it, because as your client, once again, as your clients grow, if the server is saving the state in memory of the application, this particular memory will start growing huge. And once if it's a Java application, it has a 512 MB or something of the maximum memory that it can have. If it goes beyond that, the OS will kill this application. Okay, so in order to make this scalable, so this solution is never going to be scalable, because every time you have a new client coming in, you have to basically, you're tying that client to that particular server. So you're saying that, hey, client 1 and client 2 is going to talk to only this server, client 3 and client 4 is going to talk just to this server. Okay, so you're tightly coupling these clients to this particular server. And remember this, in the software industry, if you have tight coupling anywhere, it's a recipe for disaster. Not today, but in the future, there will be issues. Okay, so what we do here is we basically say that these clients can talk to whoever they want. Okay, they can talk to this guy, they can talk to this guy, they can talk to this guy, because all the information about the communication is being saved here in the database. This database will basically, this server will ask the database any question it wants, and the database will return the answer. So keeping the data consistent is database's job. It's not the server's job anymore. Server will just return a response to the client, which means that if you have if you have many, let's say these two servers are sitting in the US, okay, and this server is sitting somewhere in Europe, okay, you have a huge number of load coming in the US. Okay, I'll take a very real example. When Flipkart sale go high, they have servers in Mumbai and then they have servers in Singapore. Okay, in order to manage the load, what they do is, when their Mumbai servers are very highly like when their servers are loaded, they basically route the traffic to Flipkart. So the load time might increase, but you will still have your queries responded. Okay, so in that case, what happens is any number of like clients can talk to any number of servers, and you don't really have to worry about keep saving the state here, because the state is being saved by the database. This is a stateless communication or stateless architecture. Any questions about this? Cool. If there are no questions, we can move on to the so now we have to understand about REST principle, what exactly REST is. Okay, we understood basically how a communication happens, what a client server architecture is, and what a stateful and stateless communication is. Okay, before I get into the REST communication, let me explain a few things to you. Okay, so there is a concept of API. Okay, and API stands for application programming interface. Okay, that's what API stands for. So what exactly this basically means is that there is, so I'll take this for example, this particular example. Okay, this is a piece of code that has an algorithm written to it. Okay, that algorithm basically does all 4 of these steps and it sends an output. All right, anyone who wants to use this particular functionality or who wants to use this entire unit, they would have to talk to this using this method, right? Extract digit str, right? This method they pass their input, and then whatever gets processed out is returned as a return type, right? This method here is actually the API. So they're never calling this particular stage, or they're never calling this particular stage. They're calling this. So the only point of communication between the outside world and your code is this method. This method is known as an API, or application programming interface. Okay. Similarly, in a web in a web service, when we talk about two applications talking to each other using internet, okay, the concept of API is slightly different. Okay, how do I know this? So let's say um, let's say let's imagine this as a Facebook server. Okay, all right. So, or should we just take this one for example? One second. Let's say this is Facebook server. All right. Each of these processing units are mapped to a particular method. This would say login. This is a login method. This is connected to a login method. Like there's a login method working behind the scene. Similarly, for this, there is get profile HTML. Let's say your Java code has two methods like this, that anytime somebody is trying to log in, they basically call this login method, which has its own mechanism to log the person in, and this get profile HTML, which basically gives you a profile HTML, which is then rendered on your browser page, because that's what happens every time we say facebook.com. We are basically trying to, if you're logged into Facebook, you'll see your profile page. If you're not logged into Facebook, you'll see this login page, right? So this is an HTML which is being sent to your page, right? So you cannot call this login method, right? I'm not typing this thing here, Facebook dot login. I'm not running this thing on my web browser, right? Neither am I saying Facebook dot get HTML. I'm not writing any code like this, right? What am I writing here? I'm writing facebook.com, maybe to log in. If I want to see my profile, I'm saying Facebook/profile. Okay. You can see that the profile automatically redirects you to this because you're not connected. So imagine that I have my own Facebook. Okay. This is my site, www.mybook.com. Okay. So I have two methods here, login and get HTML. Okay. You're never going to call this method because this method is not even there on your machine. It's sitting in some remote machine, right? So I have to do a mapping in such a way where you as a client can call something, which would trigger this login methods. For example, you have to call something here because you are sitting on a different computer. You have to call something here which would trigger this login method, or it would trigger this profile HTML method. Okay. So what generally happens is such URLs are basically given. So let's say I define that anybody who goes into his browser, be it Chrome or Safari or Firefox or anything, if they do this login, make sure that any call to this URL is going to trigger this login method behind the scene. Okay. So it gets mapped like this. Okay. Similarly, if somebody says www.mybook.com profile. Okay. Then get profile HTML. This is the method that gets triggered. Okay. This mapping, between this method and this particular URL is this entire thing, this bridging between these two things is what we do as web services or as web developers. When we say that we are designing backend APIs, this is what we do. This particular component, it's called an API endpoint. API endpoint. Okay. This entire thing, my book slash login, it's called an API endpoint. Okay. Similarly, this profile here is called an API endpoint. Okay. Now in this, there is a concept of base API, and then whatever you add to it. The base API is basically this guy here, which means anything that you want to access, you have to precede that with this particular URL. Okay. So that is your base API. And these two are your API endpoints. You can call it login API endpoint, and you can call it view profile API endpoint. Any questions here on this? Anybody wants me to explain again?
Sir, explain again, sir.
Explain this thing again? Okay, okay. Do you understand this? That you have a, let's say you have a Java program running here. You have a Spring Boot application running here, which has a login method and a get profile HTML method. This is running on your machine, right? It's running on wherever you live, your computer, it has an internet connection. Some client wants to basically reach out to you. Some client wants to say that, hey, I want to view my profile, right? Or I want to log in to view my profile. So those clients are sitting on their machines, right? They're probably using their MacBooks, or they're using their Linux machine, or they're simply doing it from their Android phone or Android application, whatever. This Java application, the Spring Boot application, is running on your machine and not on their machine. Okay. So how do you make it available to them? You have to give them something, okay, using which they can access these two methods, right? They don't call this method directly, like I told you, right? I don't say that Facebook dot login bracket. I don't do this, because that application, whatever application Facebook is running to run this entire thing, that application is not running on my machine, right? So I have to basically bridge the gap. If there is a client here, let me use this image. Okay. If this is my client, right? How is this client going to talk to me? Because he does not have access to this, right? So what we say is, I tell the client that if you want to log in, go to your browser, internet browser, and enter this URL. Okay. So what the client does is, the client basically talks to this server using this particular URL. It says that, okay, I am going to enter this URL, www.myfacebook.com/login. Okay. It says that in my web browser, I'm going to click on this, or I'm going to insert this and press enter. When I do that, it will come here to my server. Okay. And then it will basically execute this line of code. We will see in Spring Boot how that actually happens. But basically, if you go to your browser and hit this API, hit this URL, you will be able to log into my system. Okay. Similarly, I tell this guy that if you want to view your profile, just make sure you do this. There is another URL that you have to hit. Okay. Okay, never mind. Yeah, that you have to hit. Okay. So I tell this guy that if you want to call this particular method, go to your browser and hit this API. I mean, hit this URL endpoint, and then you will get your profile view. Okay. Is this part clear to you, Abhishek?
Yes, sir. That's
Right.
clear.
This is clear, right? So what I'm doing here, I'm bridging the gap between a client and my server. How am I bridging the gap? By telling the client what to do. These I have given two URL endpoints. These are called basically API endpoint. Okay. Basically, if my client visits this, they'll trigger this method. If my client visits this API, they'll click this. I mean, they'll trigger this method. Okay. There is always a method attached to this particular link. Anybody visiting this link will trigger this method. Okay. So this is called the API login API endpoint. This is called the view profile API endpoint. Okay, anybody visiting this will trigger this. This part, this particular part, which is common to all of them. Okay, it's called the base API. Okay, understood so far?
Yes, sir.
Cool. Let's take a 5 minutes break and we'll come back and we'll continue with the rest of the things. What do we have? Countdown 5. Okay, I hope everyone is back. Um, okay. So I hope everyone understood what an API is. An API in the context of web services or web application, it's basically a URL or a website, you can say, which you can hit and then you can get some result back. That's basically an API. Why is it an API? Because this is the bridge between the client and your server. Okay. Now, there are many ways you can write an API. Okay. Many different types of APIs are there. Like basically how you write an API or how you design an API decides how good your API is. Okay. So since there are many ways to write an API, one of the most used and most favored way of writing API is known as REST API. Okay. REST here stands for this thing, representational. So this is basically RE of the REST. I think it's state transfer. Okay. Representational state transfer. This is basically what REST stands for. Okay. What does this mean? Okay. What this basically means is that the client is going to have the responsibilities of sending everything for the request to be processed. What did I just say? That's confusing, right? Let me tell you what I mean by that. So REST API or RESTful architecture, let's call it RESTful architecture. Okay. Architecture, by the way, is just a standard that we follow when we're writing APIs. Okay. So this RESTful architecture says that first of all, this applies only to client server communication. If you do not have a client server communication, if you don't have a setup like this, then RESTful architecture doesn't apply there. Okay. Then it basically says that a client needs to send all pieces of information required for processing the request. Okay. What is this? What does this mean? Okay. So think about this. We'll go back to this architecture. Okay. What this statement basically means is that what this so what this basically means, this particular second line here means, is that when a client is sending a request, let that client have all the information that I need. For example, let's say that this client decides to log in, right? So what the server then sends, the server basically does this. The server goes here and sets the flag to true. Okay, let me just zoom this out, zoom this a bit. Okay, so as this client sends a login request, the server basically, let's turn this back to green so that you guys understand. Okay, let's imagine a scenario. Okay, the client here sends a login request to server 1. Server sends that, authenticates that client, and it basically sets the flag as logged in as true, right? So what then happens is the client then sends a view profile request. You as a server, what you say is, when you're sending this information, when you're sending the response back to client, you basically pass some information, something like this. Okay. This is a response by you, And in this response, let's say you pass something like this. Let's say you pass some kind of token. Okay, or basically something like a session ID. You pass this session ID to, don't worry about what a session ID is, just know that you have sent a login request to the server. The server has logged you into the database, and the database is having the state that you are now logged in. And then what the server does is the server sends you some information, okay, some session ID, some randomly generated ID back to the client. And the server says that from now on, every time you send me a request, make sure that this is coming along with it. Okay, what did I do here? I logged the client in and I sent a session ID back. Now every time this guy needs to send a request to me, he's going to attach this session ID to me. What will I do in the backend? I will capture this session ID. I will check it against the database to find out whether he's actually logged in or not. And then I will basically serve him this particular page. Now, what did I do here? I basically gave the client this particular session ID or this particular token, and the client in turn, in the next request, the client is basically sending me everything that I need to process this request. Okay, because if he, let's say this guy sends a view profile request without the session ID, right? So then this server would have to basically generate a session ID there and then check against this database, like, okay, this guy is logged in, then maybe generate something else. So every time the request comes in, right, I would have to basically do some sort of how do I say it? You have to do some preliminary work basically, and then you can send the response back. Instead of doing that, what you're telling the client is, take this particular thing with you, and every time you send me a request, give this send this thing along with the request. So what usually happens is, when the request comes to me, I already have all the information that I need to process this particular request. Whatever information that, so you are kind of offloading the work. You're offloading 20 or 30% of the work to the client. You're just telling the client that send me everything I need for processing this request, and I'll just process the request and give you back the response. Okay, this is what representational, this is what the second point says. It says the client needs to send all pieces of information required for processing the request. This is what representational state transfer is. If you see here, the state is being maintained by the database. Okay, so this server created this state for the client, and it generated the session ID on the basis of that, and then it basically sent that state as a session ID back to the client. So now every time this client sends a response, I mean the client sends a request to the server, right, it always sends this session ID. So what is happening here? This session ID is basically representing the state of the client, which is now coming from the, so the state is being transferred from this to this, and from this to this, and from this to this. This is basically the state transfer, and it is a representational state transfer. Like you can actually have, I mean, we'll get into the representational part later, but just know that there is a state being transferred from this thing to the client is now managing its own state, and the database is managing the state. The server is not managing the state in its own memory or anything. Okay, is this clear, or do you want me to explain again?
Explain again, sir.
Okay, all right. So you understood the part without the session ID, right? Whatever happened here.
Yeah, yes, sir.
Okay, so let's say I have this requirement. I tell this user that when you log in, okay, I will give you something that you have to send me with every request, so that I don't have to do some preliminary work. Okay, just think of it like this way. If this guy was sending, if this guy was basically requesting this view profile from you, right, what would you do? You would first come here, you would check that, okay, is this client is this client even logged in to my account? You would check it with the database. If this client is logged in, then you basically go ahead and send the response back to the client. Okay. Instead, what you did is you did things a little differently here. Okay. You logged the client in. Okay. And then you generated a session ID to it. Now this session ID has a expiry. Let's just say this session ID is going to expire after 10 minutes. Okay. Or, if session ID is confusing to you, let's just use the term token. Think of it as a token. Okay. So when you sent a login request, I gave you a token, and this token basically says that you're authenticated. Okay. You are now allowed to make any kind of request you want. So what the client does is the client sends this view profile request. At this point, if I don't have the token service, I would go ahead and check, is this client even authenticated with the database? Okay. So this continuous database authentication is not a very good way of doing it, because what happens essentially is it creates a huge load on the database itself. Okay. If this is confusing to you, just bear with me. Let's just say that every time a request comes, you have to check with the database, is this guy logged in, is this guy logged in, is this guy logged in? Okay. And this is just one flag with which you verify this client. There could be scenarios where you collect lots of data from the client, and then you authenticate that client against the database, and then you get a response saying, okay, this guy is authenticated, right? So you want to take that load off of database. Okay. So you are doing all of the authentication here. What you decide to do is you decide to do this. When the client sends a login request, you basically give him a token. Okay. This token has an expiry. Let's say this token has 10 minutes. And basically what you tell this client is, anytime you tell this client that anytime you need to make a further request, any more requests, just attach this token, so that I don't have to check with the database that you're logged in, because I can just look at this token, I can verify the token, and I can send the view profile to you. So what did you do here? You basically offloaded the database. You took some of the load away from the database and you gave it to the client. Okay. What is this token? This token basically says whether the client is logged in or not. So this token is, in essence, the state of the client, the state of the entire communication. As long as this token is valid, you know that the client is already logged in. That's why you see that if you use Facebook application, right, you log in once and then it stays logged in for a very long time. Maybe after like 6 months or 7 months, it asks you to log in again. Why does that happen? Because it generates a token for you, which stays with the client. So what is happening now? Every time you're basically passing a request, you're passing this token with it. So this token, which represents the state of this particular communication, is coming always with this thing. So you're basically doing a state transfer this way. Is this clear, Ankit?
Yes, sir.
Cool. Okay.
Yeah.
So REST API has a bunch of guidelines. Okay. Okay. Before I get there, let me tell you how to write a REST API. Let's say I have a library. Okay. And you as a student, you come up to a library, you walk into the library, and you basically go to different sections of the library. There's a history section, there's a science section, there's different kinds of sections. You can walk into the section and you can pick the book you want. But because of COVID, what I do is I tell everyone that you don't have to walk to the library. I will open up a service for you where you can book where you can rent your books online. Okay. So what I am going to do is I'm going to basically allow students to rent a book. Okay. I'm not sure if rent is the correct word, but yeah. And also I'm going to allow students to register. These are the two functionalities that I have to do in order to make my library available to the public. Okay. So this is how you should think, like when you're deciding, when you're given a problem statement, you will always be given a problem statement like this. Okay, design a library or design something which does these functionalities, all these things. Okay, from there you need to basically read the information and then find out what is what. Okay, so think about this. There are two things that I'm doing here. One functionality which is going to allow me to rent a book. Okay, another functionality which is going to allow anyone to register as a like a library member, right? So then what can happen here? What are the options here? The functionalities is someone, if these are the functionalities. Okay, actually let me just create a clean sheet. This might get a little, okay. There are some requirements. First requirement says that allow getting list of all books available. Okay, allow adding a new book, allow updating a book details. Okay, this is what my services, online service is going to do. Then allow registration for students, allow reading all students. Okay, allow removing a student. Similarly, yeah, allow removing a book. Okay, and allow removing a student, you know, something like this, and allow updating a student. Okay, so these are the three things that, I mean, these are the 8 things that that is required of me to do. Okay, basically somebody wants to come and rent a book from me, so that guy has to be registered. So that's why I have this registration part. And because somebody is registering, there's a possibility that that person might deregister himself. So I have to give the option to remove that person. This is how you think when you are given a problem statement like this. You have to basically think in the CRUD way. CRUD here stands for create,
Remove,
create, read,
update,
and delete. You have to
delete.
think of it in this way. Okay, so firstly you have to think what are the 2 things or 2 resources that this problem is going to deal with. Anybody coming to my system wants to know 2 things. It wants to know if there are books or not. It wants to know if there are any students or not. Okay, which means I'm dealing with 2 resources. Okay, first resource is resource 1 is my book. Resource 2 is my student. What do I mean by this resource? I am thinking completely from a web applications point of view. The web application, when somebody talks to the web application, what is it that the client is asking for? The client can ask for 2 things, either anything related to a book or anything related to a student. So I have identified the 2 resources I have. Okay, similarly, there is going to be a base URL for each of these resources. Okay, how do I do this thing? Let's say my library's name is www.mylibrary.com. Okay, this is how I'm actually building the API. This is my primary base API. Okay, this is going to be the parent of all the, like, every time you send a request, it has to come to this. Then there has to be a base API for book, because that is my resource. What is that? It will be my library.com/, books. Okay, you pay attention to this S here. Okay, the difference between a REST API and any other API is that we never write something like get all books or something like, you know, we never write something like the first funda of writing RESTful APIs is that you always treat the resource as us like if you're dealing with books or if you're dealing with students, you need to have a base API for that. You would not have a URL ending with the function. If you say add new book, that means you're exposing to the client outside what this URL is doing. The client, if the client looks this thing, if the client looks at this particular, if you look at this URL, let's say, okay, can you tell what it's doing? It can add a book, it can read a book, it can delete a book, it can do n number of things. But you, as a client, you don't know what's happening behind the scene, right? You just know that as you hit this particular URL, you are basically looking for books. Okay, can I give you an example, like a real life example? Let me see. Let's say, okay, let's just open up Google. Okay, let's go here. Okay, let's take a look at this particular URL. Okay, forget about this part. Okay, look at this. This is the base URL of Google Chrome. Okay, I mean Chrome store. Okay, now Chrome has two types of store, a web store and then the one that you can open through phone and everything, right? So anytime you are dealing with anything related to web store, you do this. Okay, and then you have some detail component. Like if I think if I hit this particular detail API, it will not return anything. Because there's no mapping to it. Okay, so basically, if you hit on this web store, it is supposed to give you the thing about the web store. If you hit this detail, it is probably supposed to give you details about the web store. If you write countdown here, it will give you all the details about countdown. But if I look at this particular URL, you cannot tell whether I'm creating a countdown object or whether I'm creating a web store object or whether I'm creating a detail object. You cannot tell. You just know that if I have come to this particular path, then I'm probably dealing with countdown. I'm probably doing something related to countdown. Okay, which means that this particular piece of code or this particular line here, this word here is just a resource. They're treating this part of the URL as a resource. So if the detail has countdown, and let's say you have something else, like for example, if I just hit this, I think this will return a 404. This will return a 404. Okay, let's say I go here, go to this extension part. Okay, check out this thing. Okay, this is a very good example of REST API. Take a look at this. This here says you are looking at every item in web store, then you're basically checking all the categories, and then there is extensions, which means right now whatever you're looking at, whatever you are doing on this particular website, you are doing it on not web store, not category, but on the extensions. Okay, why do I say this? Because REST API demands that you treat whatever the endpoint is. Okay, you always treat it as a resource. So in my case, right, this might be confusing for other people, so I'll explain again, don't worry about that. So if I am designing a book API for me, okay, for this book resources, it will always be books. Okay, similarly, if I am exposing an API, so this particular URL will handle all kinds of requests, whether you want to create a book, add a book, delete a book, see all the books, update some of the books, or remove some of the books and keep some of the books. All those calls and everything will be done through this base API. Okay, similarly for students, we will have something like this. Okay, we'll have www.mylibrary.com students. Okay, remember how I'm not giving just student, I'm giving students. That means it basically indicates that there can be one or more students. Okay. Similarly, books here can be one or more students. This thing that we saw, right? There are not many web stores. There's just one web store. This is the Chrome web store that you're looking at, right? If you had given web stores here, then it would ask you basically something like which ID of the web store. That means there are multiple web stores, which web store you want, and then you pass the ID there, and then it'll show you. But because it is given as web store, you know that there's only one particular web store. Interestingly, if you look at this URL, okay, if you look at this particular URL here, you will see that extensions is ending with a plural S. Why? Because in this page, there are many extensions here, okay? This is one of the ways you design an API. You always have to think, what am I returning? Am I returning any information about a book? Then it is going to be book. But wait, am I going to deal with multiple books? Is there going to be multiple of this thing? If there is going to be a multiple of this thing, then your naming convention says that it should end with S, okay? And you should never ever write a URL where you basically define the function name itself. Don't say something like get all books, read all books. Then for every different function, you would have to have every different, like if you say get all books, then it will be get all books. Then if you say that get first 50 books, then you'll probably have to write something like get first 50 books. This is not a very nice way of writing things, because what if tomorrow the number changes to 100? You're going to come and change the URL. What about the people who always knew this 50 books? That's why we never specify any of these things on the URL itself. We always say that if it is about books that you're dealing with, is it a single book that you're going to deal with? No, because your library can contain multiple books. So it will be books. Similarly, your library can have multiple students who register as library members. So it will be students. Okay. I'm sure some of you have confusion. So let me know if you have any confusion. I'll repeat again. Anyone? Wow. No one has a question on this?
Explain again.
Acha, ठीक है. Did you understand the concept of this primary base API?
Yes, sir.
ठीक है ना? Okay. तो अभी हम लोग क्या कर रहे हैं यहाँ पे? What are we doing? We basically, our library says that you have to do these things. You have to create a student, register a student. You have to read all the students. You have to check how many students are there in the library. You have to check how many. You have to allow if a student wants to update, edit his details, like edit his roll number or something, or edit his name, first name, last name, or email address or something like that. You have to check if some student, let's say, passes out. You don't need to keep that student in your database. So in that case, you have to remove that student, right? These are all fair options. Like these are things that are practically done, right? So here, if you see these 4 parts here, they're just dealing with one thing: book. Everything that is mentioned here, get list of all books, allow adding a new book, update a book details, removing a book details, they're talking about a single thing, that is a book. Similarly here, they're talking about a single thing, student. All right, which means that you have 2 resources. There are 2 things in your system that you're dealing with. One is a book, one is a student. Okay, you have decided that your primary base API is this because that is your domain name, this is your website. Then you are basically going to deal with, you're designing your base API for per resource. Okay, so resource number 1 is book. Okay, so your base API for book is going to be my library/books. Why? Because you are just dealing, because REST API says that if you're dealing with something, if you're dealing with a particular resource, then the last part of the URL should actually have the resource name. In my case, I am just going to deal with books. Any operation, any request that comes for books will be coming to this particular URL. Okay, that's why I have given it as, let's say, book for now. Okay, but my library system cannot have just one book, right? It will have multiple books, which is why I have designed that as books. Is this much clear to you, Ankit?
Yes, sir. Yes, sir.
Cool. And for the student, the same thing. I have one more resource, which is student, right? So my any operation on students, anything you want to do regarding students, they all have to be done using this particular API endpoint, hence the student. But because my system is going to contain more than one student, it has to be students. Okay, this much should be clear. These are the base APIs for this thing. Okay, now if you look at this particular URL, you don't know whether I'm creating or deleting or updating. So how do you know what happens here, right? So HTTP basically, REST API says that you use HTTP methods because all of these calls, they happen over HTTPS. You can see this part. This is basically a protocol. When you're talking to, when two applications are talking to each other, there are many ways they can talk. HTTPS is what we usually use. You have FTP, you have, I think, secure shell script, something like that. Normally, we don't use these things. When two applications are talking to each other, they're mostly using HTTPS. Okay, it's basically HTTP, but when they released HTTP, they could figure out that the requests were not safe. Like somebody could actually come in and read all your request body. So people who were sending password and username, those were visible. That's why they decided to come up with the concept of HTTPS. Okay, this is basically the secured version of HTTP. Right now in the industry, there is a trend of doing HTTP 2.0, which has things like gRPC and lots of other things. Okay, that's a very, very advanced thing. Like it's advanced even for me. But I'm just saying, like, if somebody is curious, maybe the folks who are working, they can learn about this thing because this is like the new future. Okay, then there's something called GraphQL. You guys can learn about that as well if you are really interested. Okay, but these things are like the future. Okay, but anyways, this is a Spring Boot basic course, so I'll teach you just the HTTPS. So what it basically says is that HTTP has certain methods. Okay, hypertext transfer protocol, that's what it stands for. Okay, this describes certain methods. It says get, post, put, delete, patch. Okay, we'll go one by one, and then there's something called option and all the other things. We won't worry about these things. Okay, so let's go one by one. Basically, REST says that if you are trying to do any read operation, for example, I want to read all the books that are there in the library, you would place a get call on this particular base API. Okay, so what is this? This get is basically the R of read. I mean, R of CRUD. Okay, post basically says that anytime you're trying to create a new resource, okay, create something new, you are going to initiate a post call. That means this is the create, meaning this is the C of CRUD. Okay, put stands for update. Yes. Okay, which means this is the U of your CRUD. Similarly, D stands for delete, which is the D of your this thing. Okay, so what the hell is patch? We'll come to this later. Okay, but for now, just know that this is what it is. So if you want to read all the books on a particular URL, you're going to do a get call on this particular URL. Okay, if you want to create a new book or add a new book, okay, you are not going to generate a URL which says add, www.mylibrary.com add new book. You won't do this. You would send a post request. Okay, a post request on this particular URL. Okay, so when you're dealing with when you're designing APIs, you're most likely going to design APIs like this: a get API, post API, put API. This is basically the update part. So you do A put, if you want to update something about an existing book, okay, there is this that you have to do. If you want to delete something, an existing, you basically have to do a delete call on this. Okay, this is basically the CRUD. We'll come to the patch part later, not for now.
Sir,
Huh.
sir, basically in HTML file in the form, we write method is equals to get, method is equals to post.
Yes.
Is that you're talking?
Yes, that's it. That's what it is. That's the get, post, put, delete, and all those things. The form is limited, as in it doesn't support more than, I think it doesn't support option or patch or something like that. It's just limited to get or post, I think. But yeah, that's basically what it is. When you design an HTML page and you write a form there, you write the action there. Action basically says where it's going to go next, and then you decide the method there. You write the method there. That's what this method is. Okay. So these are the HTTP methods. REST API basically says that if you are going to create a new book, just do a post call on this books. Don't write something stupid like add new book. Okay. This is not expected. This is not REST API. Okay. Then if you are just reading all the books, you do this. If you're updating something, you make a put call. If you're deleting something, you make a delete call on these things. Okay. But there are a few things that you have to know. There is a concept of idempotency. Okay, let's focus on this. There is a concept of idempotency. Okay, what the hell is this? Idempotency basically says if a request is a put request, you check if the resource exists or not. Okay, if the request, I'm sorry, if the resource exists, does not exist, create one. If it does exist, update it. Okay, but single request being sent multiple times should always result in same outcome. Okay, what the hell do I mean by this? Right, so we go back to the web whiteboard. I'm going to delete all of these things. Okay. 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 What do I mean by this? This is your server. Okay. This is your client. Okay. The client sends a let's talk about post call. Post a student, and it passes the name. Okay, it passes the name John. It passes the roll number as R1. Okay, and it passes that it's a male student. Okay, this is the information it passes. Let me just, this is your server. The client is basically trying to create a new student with the name John, R1, and M. M stands for whether he's male or female. Okay, what the server is going to do behind the scene is in the database, it's going to add a new entry, student 1. Okay, done. If, let's say, the same request is sent again, if the client decides to send the same request again, if it makes the post call again, or maybe on a loop, a post call is going to basically result in creation of new objects, because post is meant for creating new resources. Okay, get is, I told you here, that get basically is for reading, post is for creating. So every time you make a post call on the books API or on students API, it is going to create a new student. It is going to give birth to a new resource. This S1 and this S2, they're containing the same information. Okay, they're containing the same John R1M, but they're two different entities sitting in the database. This is what post call does, and this is called non-idempotent. Okay, this is a non-idempotent call. So what is an idempotent call? Basically, an idempotent call looks like this. Okay. Let's just send it here. Let's say you decide to do a put call, okay, on a student. Okay, put a student, you say John R1 and M. Okay, what this call does, initially there's nothing in the database, right? Let's just say that this call is not existent at this point. There's only one call that's happening to your client to server, a put call. This put call, when sent for the first time, it will result in creation of this new student, which is S1. Okay, the next time a put call comes, it is not going to create S2, S3, there are all of these things. It is going to replace it. It is going to update this thing, which is why put is always used as updating. If you say that this John, you change it to, let's say, Smith, what it'll do is, if the John was existing before and then you send another put call to this, it will go ahead and basically replace this thing. I mean, replace as in the S1 will still be there. Why am I not able to move? This S1 will still be there, but the values within the S1 are going to change. That's why put call, this is an idempotent call, which means that no matter how many times you send the same API call, no matter how many times you send the same API call with the same request, one single request, that's what this says, single request being sent multiple times should always result in the same outcome, which means if this is going out as Smith in the database, at the end of the operation, it's always going to be Smith and not John or some other name. Okay, is this concept clear? Idempotency?
Sir, in the database, if at all we do not do any validation at the server side, still the new object will not be created because of primary key and the kind of thing.
So we don't get there for now. I mean, this is on a very higher level. Because obviously a put call will need an identifier. It will need to know who it's going for, right? But basically in a REST API, the put call basically says that it is going to be an idempotent call, which means that if you're sending this thing, forget about validations. Let's say that all your validations pass through. Okay, you're going to either create a new resource, and if the resource is already created, it is always going to update the same resource. It's not going to result in multiple post calls, which is why when you're designing a post API, right, there are many times you will see that in many websites you are barred after a certain number of tries, certain number of creations, because they basically put a cap on number of post calls you can make. Why is that so? Because every time you make a post call, it is actually creating a new row in the database. It's creating a new row in the table with the same information, but it's going to be treated as a new resource. Whereas in put call, if it does exist, then if it doesn't exist, it will go ahead and create one. If it does exist, it'll just go and update. Majority of the cases in a real life scenario, we never use a put call to create a new resource. Okay, that's just in the theory. We always use a put call to update an existing resource. So typically when a put call is being sent to a server, they always have some sort of ID or identifier with which they're going to check in the database, is this entry is even there. If this entry is there, then go ahead and update this thing. But if you send the same request 100 times, it will only go and update this particular entity and not other things. Okay, is this part clear to everyone?
sir. Basically, if we see from website point of view, say like we have UI where we have four options. We can create user, we can delete user, we can update user. Say like okay. So in the first attempt, say like mother and R1 and M. So since there is no user in the database, it will directly get created, right?
If you're using a put, right?
No, post.
Post will go ahead and create that mother.
Create. And because we can initially in the pre-hand we can decide, right, sir? In the website itself we can decide, because when the user create update button, so his intention is to update the details of the user,
right?
So we can check whether the user exists or not. If the user exists, then we can update the details of the student, or we can create new one and post it in the database.
Yes, yes.
Okay, sir.
That's basically what a put call does. But ideally, in a real life scenario, you'll never use a put to create a new resource. You always create a post resource and you use a put. So when we go into designing of the API, we'll see how a put basically identifies if a resource exists or not. So put basically, if you're trying to send a put request, the first thing is it will say, okay, I know you're trying to update a student, but what is the ID of the student? I need some identifier. If you don't have the identifier, your server itself will return a 404 saying, or 400, it'll send a 400 saying bad request. Okay, but theoretically, this is what put request does. You can use a put request to create or update, but if you send the same request again and again, it will always result in the same thing. So post is for creating, get is for reading, put is for updating, and delete, as simple as it looks, delete is just for updating the particular thing. Okay, now how would an exact API going to look? Let's talk about that. Let's talk about get. Okay, let's say in my system I have books with ID 1, 2, and 3. Okay, these are the 3 books I have in my API. Anyone who does a get call on, let's say, www, I'm going to forget about the base path. I'll just write it like this. Okay, you are going to say books. Okay, when you do this thing, it will basically, the result will be all the books. Okay, let's imagine this as the book object. Okay, this has the book 1, this is the book 2, this is the book 3. Now a simple get call on this is going to give you all of this thing. If you see from a browser, you never ever make anything other than a get call. How do I know this? Let me show you this thing. If you guys, if anyone is a UI developer here, they will be able to quickly get it. But let's check this. Okay, I have opened this console here with the network tab here, and I'm typing this site, www.google.com. Let's take a look at the first thing. Okay, this is an HTML document. Okay,
go to headers.
I think it's look at this. Basically, I placed a get call here. So from your browser, if you ever do something, your browsers are always get only. They only read documents. They don't, you cannot do any post or patch or update or nothing from here. Browsers are by default always get. Okay, if that's the thing, right? Now let's say I want to read information about a particular book, which is this thing. Okay, this is how my get call will look. It will be my base path. I will always have my base path. I will have the books. Okay, but now
my book ID.
Yeah, I'm not reading all the books here. Okay, I'm reading just a particular thing. So I will say book ID. Okay, and then it will just give me the information about book 2. Okay, how is an example going to look for this? An example would look like this. Okay, let's say www.google.com/books/1 or 2. So this 2 here is the book ID, books is your resources, and google.com is your base path. That is how you do a get call. Get has a lot more things, like it has query parameters and everything. We won't get into that yet, because for us to talk about those things, we'll have to understand a JSON request. But for now, just know that if you place a get call, a simple get call on books, it will return all of the books there are. If there is none, it will return a 0, an empty list. If you have books, then it will return the list of books. If you want a specific information about a book, you pass that book ID in that URL, which means that it'll look something like this, and then it'll give you information only about this book. Okay. If you want to create a new book, it is a very straightforward thing. You just make a post call to this books API. Okay. And this has a body. It has something called request body. We'll get to the request body part later in tomorrow's tutorial. But you basically send something, you send a API request to this plus the request body, and that actually results in a creation of like it does add new book. Okay. That's what post is. Put, as I told you, you can create a new resource with put. Usually people don't do that. So what they do is they send something like this. Okay. Okay. They send something like this. What it does is that update the book with ID. Okay. So how is a URL going to look in here? It will look something like this. www. It'll look exactly like this. The URL, I'm just talking from the URL point of view. I'm not talking about the request body yet, but from the URL's point of view, this is how it'll look. So if you're making a put request, you would give the base path, which is Google in our case, then the resources, books, and then the book ID here. Book ID uniquely identifies which book you're trying to update, because put is mostly used for updating. So this and your request body, this is where the actual update request is there. This will result in updating the book with the book ID. So it will go to the database, it will fetch the record, and it will then update the book. If you don't have a book with the book ID, it will return a 400 response. We'll also go through the HTTP codes and everything. Okay. That's there. And then delete is very simple. Delete is just like a get call. Okay. Delete does not usually carry a body with it. Delete is something like this. Okay. You don't have any request body with it. It will just result in deletion of book with book ID, and that's it. So the path would look something like this. Any questions so far, guys? Anyone about what I did? This is
No
how,
questions, sir.
no questions, right? Okay, you guys are submitting the feedback, right? Every day. If you guys are not submitting,
Yes, sir. Submit. But
so
I want to confirm your two's name. Your name is Arijit.
my name is Arijit Banerjee. Yes, and the practice guy is I think Neeraj.
ओके सर. आपका तो हमेशा दिया ही है फीडबैक. सर का मिस कर दिया क्योंकि मेरे को नाम नहीं पता था इसको.
हाँ ठीक है, उसका भी दे देना ठीक, क्योंकि मतलब वो लोग थोड़ा प्रेशराइज करेंगे आप सब स्टूडेंट्स को बोलो कि फीडबैक देने के लिए, बिकॉज देयर आर मेनी स्टूडेंट्स जिनको प्रॉपर्ली समझ में नहीं आता है, तो विल हैव टू अंडरस्टैंड कि उसको क्या क्या समझ में नहीं आता है, तो मे बी अलग से सेशन करवाएगा या फॉर दैट रीजन.
यस सर, मैंने डाल भी दिया था, मैंने डाला था.
हाँ ठीक है, तो दिस इज फॉर एवरीवन, जस्ट काइंडली give the feedback. Okay. And yeah, that's basically what it is. So we have learned quite a few things here. If you are, if it's difficult for you to understand, go through the video again. I think I've done a good job explaining things, but if you are still confused about something, get back to me and I'll answer. But yeah, today's session is only this much. In the next session, we'll get more into the actual REST APIs. Okay, I think by the this actually has like 3 sessions. One was today. We'll have 2 more sessions. After these 3 sessions, you will be comfortable with a REST API. You will know terminologies like get call, post call, put call. You will be familiar with the JSON request. You will be familiar with request headers, request response body, and all those things. Okay. So,
XML.
Yeah, no, XML we're not teaching. Again, XML is something we do not teach because XML is like most companies don't use XML these days. If you are working on an XML project, it's a very old project. Okay, XML.
Oh.
Yeah. So we're not going to teach XML. We'll just focus on the JSON part. Okay, that's that. But yeah, I mean, if you want to understand how a JSON request looks like in XML, we can do that. That's there. And yeah, that should be it. Okay, one more thing is, you guys just go ahead and familiarize yourself with this, okay? Bceptor. This is a mock API platform, okay? It allows you to create an API endpoint with methods defined in it: get method, post method, put method. On the third session, we'll actually have a walkthrough using this thing. This is a mock API. It has hard-coded response. So whatever request you send to this thing, you'll get the response back. We will also learn about Postman, which is something we're going to heavily use when we are building our backend service, okay? So yep, that's all for now. All right, if no one has any more questions, we can end the session. Cool. Thank you and good night.